To solve this problem, we just simply first find the external reactions. So take the entire thing as system. There you go. Let this point be AB and C and D, pin right here, so dy. Then you have 3K20 and you distribute the load here, 6 kilonewton per meter, couple moment, 5K, and AY, and obviously AX. And no external moment at A because pin. So that's your system. So you go ahead and write the equation, summation of force x0 AX plus 3K sine 20 equal to 0, summation of force in y0 AY minus 6K minus 3K cosine 20 plus dy is equal to 0. Summation of moment obviously about A 0. Then you get negative 5K negative 6K times this distance between here, the center of that, and point A, which is 2.5, 2.5, and then you get negative 3K cosine 20 times this distance, which is 1, 2, 3, 4, and then finally plus dy times 1, 2, 3, 4, 5 is equal to 0. Now you solve it. You solve the first equation. Let's use another color. So it gives you AX is equal to, put in a calculator. So AX, where is my calculator? Alright. 3 times sine 20 with a negative sign. So 3 times sine 20 and negative 1.026, negative 1.026. Don't forget, if you want to end up with 3 significant digits in the end, you have to keep 4 digits in your computation. So the truncation error, when you actually get rid of truncation error, you round up to the 3 significant digits. So excuse me. So you have negative 1.026K, and you solve. Now you solve equation number 3. Get rid of one equation, one unknown, so you get 5 plus, put it inside parentheses. Okay, let me close this thing. Got some calculator problem. Alright, so 5 plus 6 times 2.5 plus 3 times 4 times cosine 20 divided by 5. Dy is positive. So if you solve that, this gives you dy 6.255.255K, and then you put it to get AY. So AY is equal to negative 6K negative 3 times cosine 20 plus 6.255 and then you take it to right, AY become positive 2.56. There is a 4 here too. K 2.56. So these are the data you get when you solve external reactions. So let's go ahead and put it right here on the figure, on the original figure. So there's gonna be AX, which obviously goes this way and is equal to 1.026K. AY goes this way and is 2.564K, and there is going to be a dy, and this dy is 6.255K. Now let's get rid of this computations here. open up some extra space. Alright, again, let's see if I can select a region and delete the region. Can I do that? How can I delete that? Now, I wish I could select. If you know how to, on iPad, how to select a region and delete, let me know, because this will save a lot of time. Okay, so we go. Now, the objective is to find the internal loading at the very center of the beam. That means 2.5 from either left or right. So what I'm going to do right now, I'm going to cut it in the center. See, cut it right here. Then I have always, any cut gives me two options, one on the right or one on the left. I choose the one on the right because, I mean, in this case really there is not much of a big difference, because you know, in either case you have distributed load and some sort of other loads, but you know, I just choose the one on the right. So, but just to show for educational purpose, because when I was grading I saw some students did it wrong, I'm going to draw FPD for both parts, the one on the right and the one on the left. So the one on the right is, take it this, the one on the left, put some separation space, that. Now you have 6.255K go this way. Again, look, in the exam, if you get two significant digits or 3 or 4, I mean, I don't really care. I'm not picky about numbers, as you have already seen. You need to do the right procedures, right signs, right equations, right steps. I mean, the number calculator can do that for you. So here, if in exam, if you just simply write 2.6.2, for example, 5, that's just fine. Okay, even if you put 6 point, let's say 3, that's just fine. Okay, your end result may be a little bit different, but it's all right with me. So let's go ahead, put the external loading on the system, 6.255K, and here you have this 3K, distance 20 degree here, and then you have a part of distributed load, it's just half of it there, 6 kilonewton per meter, and then you have N, normal force at point in the middle, just call it N, don't put a sub, makes it easy. And then V goes up, that's very important. I saw some student put the V down, right? These three components, on the right part, V always going upward, then on the left part, V goes down, according to the Newton's third law. law of action and reaction, just the same value but opposite direction. Also n goes this way on the left part, and then your bending moment is always, it bends the beam toward upward positive, so it's this way on the right and this way positive on the left. That's what you get for the point that we cut, right? And then you don't have external forces, but you don't have body force for the beam. The weight is small. So I'm done with FED on the right. Let's go to the FED on the left. Then you have external couple moment here, 5K. Then you have 2.564K and 1.026K goes this way. And don't forget, you also have a part of this distributed load because we cut it in the middle, and its top is 6 kilonewton per meter. Okay, so this is the FVD for 1.026K for the system on the left. That's a complete FVD for the system on the left. Now I can choose either one, and you should get exactly the same result. It doesn't matter if you choose the one on the right or left. Alright, so as I mentioned before, I choose this one. So let's call this system 1, and let's call this system 2. So all the equations I'm going to be writing here is for system 2, right? So let's go ahead and write equation, summation of forces. Because it's a 2D, I'm just repeating myself, because it's a 2D, we have 3 equations. If it was 3D, we would have 6 equations. Summation of force in x0, summation of forces in y0, summation of moment about any point should be 0. That point, I'll just call this point A, the one in the middle. Well, we already have A, B, C, D. Let's call this E. You see, we already have A here. Let me circulate A here, B here, C here, D here. So in order to not have a duplicate symbol, let's call that point E. Okay, so put this point, hold on, undo, redo, okay, E, and the same E here, that's the same point. Okay, so sub E, summation of moment about point E must be 0. So let's expand these equations to get something useful. The first equation for the system on the right is going to give you negative n plus 3k sine 20 is equal to 0. The second one is going to give you plus v, and no n, no m, then you get negative 6k times the base, which is 0.5. Okay, negative 3k cosine 20 and plus final 6.255k is equal to 0. And for moment you get negative m at, or just you can say m sub e, or you can just simply say m, right? So negative m, negative 6k times 0.5, that's the value of force, times this is force, distributed force, times moment arm, which is half of 0.5. Okay, and it's negative, and you go ahead, and for 3k then you get negative 3k cosine 20 times that distance, which is 1.5 times 1.5, and finally you get plus 6.255k times 2.5. 2.5, this summation must end up to 0. Now let's solve it. Okay, when you solve the first one, you get 3k times sine 20. So your n, the axial load or normal load, 1.026 K positive. So you have tension. Then you solve for shear load. Shear load is negative 6.5 negative 3 times cosine 20 plus 6.255 is equal to a positive, and you take it to right, becomes negative. So your V, let's write it here. If you solve that, your V becomes negative 0.436 K, or 436 Newton. So let's double check that. 6 times 0.5 negative 3 times cosine 20 plus 6.255, and then you take it to the right, become negative. Okay, and finally your moment becomes negative 6 times 0.5 times half with a negative side. It's negative 6.5, and negative 3 times cosine 20 times 1.5 plus 6 times 255 times 2.5. Okay, your M, bending moment, is 10.66. Okay, well, obviously here you just simply say 10.7 because you want to have 3 significant digits. 10.6 actually, sorry. 10.6. Let's see if I 10.6, because originally that value is 10.658. Okay, so you put 10.6, and this is 3 components of your values, and n was equal to, n was 1.02. You can put 1.03 K to round that value up. So you have 3 components. The answer to the question is you have 3 components at point A, and those values are given here. So I'm going to, this enough for this video. I'm going to have another video for quiz number 3. This is the answer to quiz number 2.